Hi, in this video, we will define another operation on sets, complement of a set. To be able to define complement of a set, we first need to know what is called universal set. So universal set is something that is going to be given in the question, or it will be obviously clear what is the universal set. And by the universal set, we mean the set of all possible elements considered in the problem, in the question, or in the context that we are working in any. And we denote it by U. Well, examples of that. If you're working with an example which only has some integer numbers, then you can take the universal set to be the whole set of integer numbers. Or if you're working with an example in which the sets have letters, English letters, the set of all alphabet is the universal set. But something that you have to know is that the universal set is going to be given explicitly either or, it will be clear what is the universal set. And when it comes to the Venn diagrams, the box that we draw around our diagrams is basically the universal set. Meaning that, I won't have any set to go outside of that box. That is not allowed. Universal, everything must happen inside universal set. Okay, knowing the universal set, now I can define what is the complement of a set. Taking complement of a set is a little bit different than taking union or taking intersection. For the union and intersection, I needed two sets, but for the complement, I only need one set. So the complement of a set A is another set of all elements of the universal set which are not in A. So you take anything outside A, obviously inside the universal set, yes. And what is the notation for that? We denote the complement of A denoted by A superscript C. Just read it A complement, okay? And when it comes to the Venn diagrams, so if this is my universal set and this is, say, my set A, then anything outside of A is called A complement. So here in this case, the region shaded by red is A complement. Let's do some examples. Okay, starting with this one, I have been given the universal set. Universal set is the set of numbers from 1 to 7. And A is 2, 3, 5, 7. B is 2, 3, 4, 5. And C is 2, 4, 6. Yep. Now, let's find what is A complement. So A complement means that everything which is in the universal set but not in A. So I go one by one. Is 1 in A? Is 1 in A? Well, the Answer is no. So I will include it in A complement. Is 2 in A? Yes, it is. So that means that I won't include it in A complement. Is C in A? Is 3 in A? It is not. It is in A, so I won't include it in the complement. How about 4? 4 is not in A, so I will include in the complement, and the next thing is 6. So you continue that way and you find A complement. How about A intersection B then complement? So see, the brackets basically tells us what is the order. It says that first find the intersection of A and B. So here in this case, this is 2, 3, 5, 7. Find the intersection, but with 2, 3, 4, and 5. I am not applying complement yet. So first I want to find the intersection of these two sets, A and B. So 2 is there in both of them. 2 is in both of them. 3 is in both of them. And 5 is in both of them. Now that I found the intersection, it's time to take the complement. The complement is anything which is in the universal set, in this case 1 to 7, which are not in the set given here. So it will be 1, 4, 6, and 7. Taking complement, yes? How about the third one? So this says first take complement of A, take complement of B, then find the intersection. You see, there's no brackets, so that means. So first, I found the complement of A. I already found it actually in the part B. Then find the intersection of complement of B. Let's see, what is B? 2, 3, 4, 5. The complement would be 1. Whatever is in the universal set, which is not in B. So 1 and 6 and 7. What is the intersection? Well, intersection is both of them include 1, both of them include 6. That's the intersection. How about this one? A union BC. So here, you should not confuse this thing with this, because there is no bracket. It actually means that, you first find the complement of B and then find its union with A. So let's just see, what is A? A is up there. So let me just focus a little bit. 2, 3, 5, and 7. And I want to find union of that with not with B, but with its complement. So here, complement of B, we already actually found in the example. So 1, 6, and 7. Now you have these two sets. Where they did come from, I don't care now. I just want to find the union. The next step is find the union. So put everything which is, put all the elements of these two sets together and form that union. How about this one? The fifth is A complement intercept B union C complement. So here again, you have to go one by one. This means first you have to do this. Then you have to take the intersection. This is the second one. Then when you're done with that, you go actually you could have done this one at the first step as well. So, and then when you're done with that, you take the union of the whole two sets. So let's go one by one. So first thing is, what is A complement? A complement we already found. This is 1, 4, 6. Then we want to find its intersection with B B. B was 2, 3, 4, and 5. And then, so that is A complement. This is B. Then I want to find union of that with C. What is C complement? C complement, C is that C complement is going to be 1, 3, 5, and 7. Yes? So it will be 1, 3, 5, and 7. Now, I want to find the intersection first. What is the intersection of these two sets? 1 is not there, 2 is not there, 3 is not there, 4 is there, and that's it. So the intersection of these two gives you a set with one element. Then find its union with 1, 3, 5, and 7, and that is union. Yes, so you put all the entries together, you get 1, 3, 4, 5, and 7. There is one last one. This is the 6th one. So CC intersection BC. So here again, we have to first find this one, then find this one, and then find the complement. That's the third thing we have to do. So let's go one by one. So I will keep that one out there. B, I want to keep it there. So what is B? B is 2, 3, 4, and 5. Yeah, 2, 3, and 4, and 5. And C complement. C complement is what we found up there. Yes, 1, 3, 5, and 7. And now that I did find C complement, and I know what is B, I can find their intersection. What is the intersection of these two? Well, 2 is not there, so 1 is not on B, 3 is in both of them, and 5 is in both of them. But then the last thing goes up there. So I want to find complement of the set 3 and 5. So I know the universal set is 1 to 7, so it will be 1, 2, 4, and 6, and 7. Yeah. And that's how you do work with the complement. I have one more example here expressing the sets in terms of the set notation. Okay, so here the question we already did in another video, this one. So we have the set of Brescia students, then set of students who are taking finite math, and the students who are taking what is that, algebra, linear algebra. And as you're reading through the question, you see this thing given there, the set of all students of main campus and all affiliated colleges. So that means that that is our universal set. So we are not going outside of this set. Everyone who is a student of main campus or any affiliated colleges includes everything that we want to have here. Okay, now first one says set of all students who only enrolled in finite math. Only enrolled in finite math. Well, if you write just F, it may have some pieces which are included in linear algebra, yes? So you have students who are taking finite math and linear algebra. But we are interested in only in finite math. So we want to only finite math here means that finite and this is finite math, and not in algebra. So if you look at the wording, only finite math means taking finite math and not taking algebra, yes? So finite math is F, and here means find the intersection. Not in algebra, that is a complement. So when someone says only students who are enrolled in only finite math, that means F intersection A complement. How about this? The set of non-Brescia students who enrolled in finite math. Well, not Brescia and enrolled in finite math. Yes. How about the third one? The set of all Brescia students who enrolled in neither finite math nor linear algebra. So let's just write this down. Neither finite nor algebra. Yes. So what does this mean? Can I write this thing in another way? I can say that, okay, neither finite nor algebra means that not in finite and not in algebra. And not in finite is F complement. Not in algebra is A complement. And here means that you find those ones. But what are we looking for here? It says set of set of all Brescia students who are enrolled in neither. So not only I want this one, I also want and being in Brescia or Brescia student. So that means that we are dealing with B intersection F complement that's. And the last one, the set of all students who enrolled in either finite math or linear algebra, but not in both. This is a little bit tricky one. So for that, I will draw you a Venn diagram. So if this is our student universal set, and this is linear algebra, and this is finite math, what you are interested in is that the students who enrolled in only one of these guys, in either this or that, but not in both. Not in both is these are the both in F and A. So how do we see this thing? So the set of all students who enrolled in either finite or linear algebra, but not in both. Yes. So for that, I will break this down into two pieces. This piece and that piece. And then, well, I know that I have to put them together. So I will find the union of these guys. So let me erase this piece here. So if I know each one of these guys, at the end, I will find the union. But what is this first piece? This is the student who taking algebra, but not finite math. This is algebra and not finite. So that is one side. How about this other one? These are the students who are taking finite and not taking algebra. And well, take the union of those and you have it. A, algebra, but not finite, or finite and not algebra. So this way you have expressed everything in terms of set notations.